Hey everyone, welcome to Simplilearn's YouTube channel. In this session, we will be learning IoT full course. But before we begin, let me tell you guys that we have daily updates on multiple technologies. So, if you're a tech geek in a continuous hunt for latest technological trends, then consider getting subscribed to our YouTube channel and don't forget to hit that bell icon to never miss an update from Simplilearn. Now, without further ado, let's get started with the agenda for today's session. First, we will begin with a quick crash course on IoT, where we will learn what exactly is IoT and the fundamental concepts of Internet of Things. Followed by the crash course on IoT, we will learn what is Arduino. Once we understand what exactly is Arduino, we will dive into the Raspberry Pi. Once we are done with the fundamentals and technical concepts of Arduino and Raspberry Pi, we will discuss the critical differences between the both. So once having a better understanding of what are Raspberry Pi and Arduino and their critical differences between each of them, we will try to develop some projects based on both Arduino and Raspberry Pi. Once we have the best understanding of Arduino and Raspberry Pi, we will dive deep into Raspberry Pi Zero. Once we are done with the Raspberry Pi Zero, we will dive into the latest version of Raspberry Pi, that is Raspberry Pi 4. So these are the agenda pointers that we will be discussing today. Hope I made myself clear with the agenda. Now over to our training experts.
Until recently, access to the internet was limited via devices like the desktop, tablet or smartphone. But now with the Internet of Things, aka IoT, practically all appliances can be connected to the internet and monitored remotely. It is a system of interconnected devices that transfer data over a wireless network without any human intervention. So hey everyone, in this video we help you understand what IoT is and how it is impacting our day-to-day life. We will also understand the IoT architecture and look at the new trending IoT projects for 2021. But before that, if you haven't subscribed to our channel already, make sure to hit the subscribe button and the bell icon to never miss an update. I'm sure you're excited to learn, so let's dive right in.
Imagine you're at work and realize that you might not have turned off the air conditioner while leaving your house. Instead of traveling all the way back home, what if you could use your smartphone to know the status of your AC and perhaps even turn it off? Wouldn't that be amazing? Well, yes. And this can be achieved with the help of the Internet of Things. Until recently, access to the internet was limited via devices like the desktop, tablet, or smartphone. But now, with IoT, practically all appliances can be connected to the internet and monitored remotely. IoT is shaping the way we live our lives. It helps us get a better insight into the working of things around us. So, what exactly is the Internet of Things? IoT is a system of interrelated devices connected to the internet to transfer and receive data from one to the other. A smart home is the best example of IoT. Home appliances like the AC, doorbell, thermostats, smoke detectors, water heaters, and security alarms can be interconnected to share data with the user over a mobile application. The user can now get detailed insight into the working of the devices around him. Think about it. Until recently, the internet helped people connect and interact with each other. But now, inanimate objects or things have the ability to sense the surroundings, to interact and collaborate with one another. For example, in the morning when your alarm goes off, the IoT system can open the window blinds, turn on the coffee pot for you, and even turn on the water heater. Although all of this is fascinating, there's a lot that goes on in the background to ensure seamless functioning. From effective communication between devices to accurate processing of the data received, a lot of components are involved. In the context of IoT devices, hardware can be classified into general devices and sensing devices. The general devices are the main components of the data hub and information exchange. They are connected either by wired or wireless interfaces. Home appliances are a classic example of such devices. The sensing devices, on the other hand, include sensors and actuators. They measure the temperature, humidity, light intensity, and other parameters. These IoT devices are connected to the network with the help of gateways. These gateways, or processing nodes, process the information collected from the sensors and transfer it to the cloud. The cloud acts as both the storage and processing unit. Actions are performed on the collected data for further learning and inferences. Wired and wireless interfaces like Wi-Fi, Bluetooth, Zigbee, GSMs, and so on are used to provide connectivity. To ensure its ubiquity, applications need to support a diverse set of devices and communication protocols, from tiny sensors capable of sensing and reporting the desired factor, to powerful back-end servers that are utilized for data analysis and knowledge extraction. To help you understand its working, let's take a simple scenario. Let's suppose you want to water your garden every time the moisture level in the soil drops. Instead of doing it manually, you could automate it using IoT. The sensors and actuators installed gauge the soil for its moisture. This information is sent to the IoT gateway with the help of communication protocols like MQTT or HTTP. The gateway significantly aggregates data and feeds it to the cloud with the help of Wi-Fi LAN. Once the moisture level drops, the system is immediately triggered and the sprinklers are turned on. However, with the information stored in the cloud, a detailed analysis like the time of the day the sprinkler was turned on, the rate at which the moisture in the soil reduces, and so on, can be done, and the report could be sent over to you on your smartphone over an app. With the improved response, monitoring, and analytical capabilities, IoT is being adopted in almost all industries and domains, opening doors to endless applications. Today, IoT is being used extensively to lessen the burden on humans. To name a few, IoT is deployed for smart homes, wearables, watches and bracelets, smart cars, smart farming, smart retail, smart grids, smart city, and smart healthcare. With such a wide spectrum of applications, the future of IT looks more promising than ever before. In 2018, there were about 23 billion connected devices, which was more than double the world population. According to experts, there will be over 80 billion devices by 2025. IoT is a vision to connect all devices with the power of the internet, always learning and always growing. Now that you have a picture of what IoT is, here's a simple question for you. Which of the following technologies is not used as an interface for a network? 1. Wi-Fi. 2. Ethernet. 3. Zigbee. 4. VPN. Give it a thought and leave your answers in the comment section below. 3 lucky winners will receive Amazon gift vouchers. The integration of IoT with other technologies like cloud computing, machine learning, and artificial intelligence is paving the way for many new and exciting innovations. And that is the Internet of Things for you in short.
The first wave of the internet revolution came in with the growth of personal computers. And in the second wave, the internet came right onto our palms. That is, with the advent of mobile devices. And here we are living the third wave, where all electronic devices are almost already connected to the internet, or will be in the near future. Yes, the Internet of Things will bring about the next industrial revolution and will drastically transform the way we live and experience technology today. Quite possibly, the Internet of Things will be as disruptive as the internet itself, particularly when combined with big data and predictive analytics. But what exactly is IoT? The concept behind IoT is about connecting just about everything to the internet in real time, which directly improves our quality of life and experiences. For instance, how are you watching this video right now? On a PC, a mobile, or a tablet? Well, whichever device you're using, it's definitely connected to the internet, and that means you're already using an IoT device. Sensors are becoming the endpoints of IoT networks. Wondering what exactly a sensor is? These sensors collect an increasing amount of context-aware data and information such as location, images, weather conditions, and inject them into networks, actuators, and applications in real time. Big data, analytics, and predictions have become apparent synonymous, helping perform and execute tasks seamlessly with minimal to zero errors. Are you ready to admit a major breakthrough? Life in the present is great, but the future looks like it could be way more exciting. How, you may ask? Since there are billions of physical devices around the world that are now connected to the internet, collecting and sharing data in real time, terabytes of data are going to become petabytes, which represents 1,000 terabytes each. There is going to be a shift from wideband networks to narrowband networks for better range. And you'll also soon witness the communication system transcend from 4G to 5G wireless communications. IoT will definitely be the paradigm shift of effective multitasking with massive applications. Now, let's have a look at the future with IoT environment. Imagine you're driving your smart car to work and you're quite late. Don't you worry, because your car can now provide the shortest route with less congestion. Not only that, the integrated sensors in the car alerts you about mechanical assistance. You also have the access to automatic temperature control, and not to forget, in case you're tired or weary, the car becomes self-driven since it comes with an accident prevention system. As you're driving, you see the smart farms through your window. Farmers are happier thanks to IoT, which help them with better yield and provided more efficiency than ever. You might wonder how. With the help of systems like autonomous self-driving tractors, adaptive irrigation systems, soil health monitoring, and animal welfare monitoring systems, this is possible. You also see smart factories which use IIoT, that is, Industrial Internet of Things. With the help of analytics and automation systems, IIoT helps in tracking goods in real time, inventory management, automated delivery system, and much more. Now you're returning home from office. Your car can park itself automatically. Your fingerprint, voice, or even your smartphone is enough to control all home appliances, from lights to television and your door to water taps too. Are you excited to experience this smart future which is not far away? Of course you should be. The applications of IoT will be seen in every industry across sectors, be it education, healthcare, manufacturing, automotive, you name it. IoT is definitely going to have a role to play in each one of them. Possibly the fourth wave will be the Internet of Everything, or IoE, which would encompass all physical things, processes, data, and people through wearables and surgically implanted sensors, unlike IoT, which focuses only on physical devices. Change is the only constant, and the world will never be the same with the growth of ubiquitous connectivity. And IoT is sure to change the way billions of people live their lives today.
The wide Internet of Things. As a learner, you should learn IoT, as it provides better scope for future data scientists, as well as provides for promising career opportunities. You can also build and manage your own IoT for your home. As a company executive, you should learn IoT, because it will help you measure everything in the business. You also get real-time metrics, actionable data, and better connectivity across industries. After completing this course, you should be able to explain the concept of Internet of Things comprehensively, describe hardware, software, and other connectivity building blocks of IoT, describe design considerations pertaining architecture, framework, and interoperability, explain the security considerations with IoT pertaining to vulnerabilities, explain Industry 4.0, Internet of Everything, and social IoT, and finally, describe IoT framework in enterprises.
In the context of IoT devices, hardware can be divided into two categories: general devices and sensing devices. The general devices do the embedded processing and connectivity for the platforms. They are connected either by wired network or wireless interfaces. They are the main component for data collection and information processing. The current home appliances are a classic example of such devices that are controlled by a sensor. These sensors help solve common problems. Apart from sensors, actuators are another important device in IoT that performs similar functions with different capabilities. They work as interface between sensors and machines and collect various information like humidity and light intensity. This information is computed using the edge layer, which typically sits between the cloud and the sensor. They are the layers that store the intermittent transfer of information. Finally, the back-end server of the cloud processes this information. Both the sensors and actuators are the chief components of IoT. The sensors measure temperature, humidity, light intensity, and other key parameters of home environment. The second most crucial aspect of IoT is device management platforms, or DMPs. The DMPs, as they are shortly called, are the platforms through which the assets interact with the software layer through network gateways. DMPs come with various functionalities, which include firmware upgrades, security patching, and reporting of metrics. They also help develop alert mechanism for industrial equipment with more open source OS like Arduino. Overall, it is an important aspect of the management of the device penetration. Connectivity blocks. Connectivity blocks collectively is considered as the backbone of an IoT setup. There are various connectivity layers like USB, CAN protocols, and Modbus. The next generation protocols of Wi-Fi are LoRa and Zigbee. They can interface with any application or modules, a small device embedded in an object. The entire landscape is called gateway architecture. The various ports are 232.485 from USB. They come with gateway architecture. The device interface is important for the data transfer and enables digital transformation with third-party applications and systems. Communication protocols and standards. Let us try to understand the various communication protocols available to set up an IoT. The first is the satellite. This enables a cell phone communication through an antenna situated within 10 to 15 miles. They have a stable and universal connection. The second is the Wi-Fi, and is based on 5 GHz frequencies. It provides internet access within a certain range and are an affordable option. It has well-protected protocols. The third is the radio frequency. It is the easiest form of communication. A few examples are Zigbee and Z-Wave, which use low-power RF radio. It consumes low energy, which is very advantageous. It is relatively simple to configure. The fourth in this list is the Rfid. It uses wireless electromagnetic fields to identify sensors and objects. The good thing about it is that it does not require power. The fifth is Bluetooth, which is useful for short-term and short-distance data exchange. It is present in every smartphone and has sensors. The final one is Near-Field Communication, or NFC. It uses electromagnetic induction and loop antennas. It comes with encryption, has low-speed communication, and is used for short-range data exchange. Future of IoT connectivity. IoT connectivity is the future, the launch of new technologies like 5G. The 5G with low latency and higher throughput will increase the penetration of IoT. 5G cellular technology is supported by the network for virtualization, even for the common use case, such as for a tea vendor, real-time predictive analytics can be available. So, overall, the delivery time is reduced with IoT. 5G and IoT are embedded technologies. Both can be sliced and diced for predictive analytics and real-time business decisions. 5G will help devices connect through a network with high-speed bandwidth. IoT Device Architecture. There are 4 layers in the device architecture. The base layer consists of IoT devices. This includes all the components, like sensors, with the ability to sense, compute, and connect to other devices. Let's move on to the second layer, which is the IoT gateway or aggregation layer. This layer significantly aggregates data from various sensors. These 2 layers form the definition engine, and they set the rules for data aggregation. The next layer is based on cloud. It's called the processing engine or event processing layer. It has numerous algorithms and data processing elements that are ultimately displayed on a dashboard. This layer basically processes the data obtained from the sensor layer. The last layer is called the application layer, or API management layer. It acts as an interface between third-party application and infrastructure. The entire landscape is supported by device managers and identity and access managers, which are useful for security of the architecture. Many individuals and organizations have contributed to create and set this standard. It covers the entire network and endpoint systems. It brings a structural approach with security controls in place. It provides a demarcation based on its uses for enterprise that build IoT products. This standard has 85 detailed recommendations and a structured approach that can fit into any IoT ecosystem. It has a flexible framework addressing the diversity of the technology aligned to the regulation. It also has risk modeling capabilities for any organization to choose from, including endpoint ecosystems. The standard is very flexible and comes with the inbuilt risk assessments for any organization to adapt. Overall, it is an interesting standard and easy to get trained at. IoT security, best practices. There are many best practices in IoT security. Let us look at some best practices pertaining to IoT hardware. First of all, the hardware should be tamper-proof. They should have undergone dynamic testing with specific data protection algorithms and should be updated on firmware and patches. The network components must be authentic with encryption, kernel controls, and division of networks into segments. Other security measures include privacy protection for sensitive information and other regulations like safe harbor statements. There are many value drivers to help the Internet of Everything. The key drivers are employee productivity, supply and logistics, customer experiences, innovation, and time to market, asset utilization. All the factors are tightly linked to generate a new revenue gains for any enterprise. Time to market and innovation. This will help with the competitive index of the organization. It will help discover MVP to reduce the cost of building and bring improvement in customer experience. Asset utilization is the form of digital, physical, and even smart assets. The asset discovery is the requirement for the establishment of the IoT ecosystem. Supply chain is also a key value driver and assesses the requirement of Internet of Everything. In addition to the drivers, there are significant elements. The elements stand in 4 buckets. The first is data, which encapsulates sending and analyzing data. The second bucket is the people, who are always connected and have contextual subject mapping with the real-time world for decision-making. The third bucket is the things which link people to machine with endpoints, IP addresses, and sensors. The last bucket is machine to data, which talks about business value and action iteration, essentially building simple models to achieve corporate results. Internet of Everything. Growth engine. The Internet of Everything comes with a growth engine for any organization. It includes people, who are the most valuable resources. The process of making the right effort for the things that includes the physical devices, other objects, and the data taken from sensors to make actionable insights for decision-making is important. People, process, things, and data are the growth engine elements that gives a company an edge in the digital transformation world. With data privacy and transparency mechanism, it is important for every organization to follow internet ethics and compliance. IoT and fleet management. Let's discuss some use cases of IoT. The fleet management is a classic example of IoT in application. In this domain, IoT is mainly used to track vehicles from one point to another. Using IoT technology, the entire fleet can be monitored with the support of RFID chips embedded within every car in the fleet. The same RFID can also be used to track products such as consumer goods, electronics, and food items. You can get real-time information on the routes that the fleet takes. There are OBD devices that can be used to track vehicles' behavior and performance, including fuel consumption and mileage. This can reduce the total cost and provide greater return on investment. According to a recent study, the IoT market will increase to $8.28 billion by 2021. Sensors linked to artificial intelligence help the bankers track all the activities in the back end. The advancements of mobile phones and digital assistants, along with 5G connectivity, makes customer experience seamless. First and foremost, it is data. Data is the new oil. Financial institutions have structured and unstructured data of the customers. They can slice and dice the data for profiling, segmentation, product launches, and digital services enablement. The data can create a large economic drive and give rise to new business models like NFC banking, digital assistance banking, and social media banking. With this transformation, Internet of Things provides a competitive advantage to the banking, insurance, and financial services, while the end goal remains to help customers save money and give a bundle offer. Let's understand how IoT revolutionizes various industries. With the advent of the Internet of Things, there are many industries experiencing digital transformation, such as financial services, healthcare, manufacturing, communications, energy, retail, and transportation. IoT has initiated changes at all levels: user, infrastructure, and large-scale applications. Analytics with real-time dashboard and IoT support allows informed decision-making for businesses. This also means that IoT is introducing a new revenue model for enterprises around the world. Learning objectives. By the end of this lesson, you'll be able to explain the IoT architecture and frameworks, describe the IoT interoperability and its design considerations, and discuss industry-aligned use cases. IoT Device Architecture. There are 4 layers in the device architecture. The base layer consists of IoT devices. This includes all the components, like sensors, with the ability to sense, compute, and connect to other devices. Let's move on to the second layer, which is the IoT gateway or aggregation layer. This layer significantly aggregates data from various sensors. These 2 layers form the definition engine, and they set the rules for data aggregation. The next layer is based on cloud. It's called the processing engine or event processing layer. It has numerous algorithms and data processing elements
that are ultimately displayed on a dashboard. This layer basically processes the data obtained from the sensor layer. The last layer is called the application layer, or API management layer. It acts as an interface between third-party application and infrastructure. The entire landscape is supported by device managers and identity and access managers, which are useful for security of the architecture. IoT Reference Architecture. Next, let's learn about the various layers in the IoT Reference Architecture. Device layer. The device layer is the main component where there are various devices like sensors that are interconnected. Some examples are Bluetooth connected via mobile phone and Zigbee via Zigbee gateway. The other devices include the Raspberry Pi that's connected to the Ethernet via Wi-Fi. This is directly connected to the communication layers, which are part of the second layer. Communication layer. The communication layer, or gateway layer, has REST protocols and other application level protocols. Both the layers are tightly coupled and generate an enormous amount of data. Now, the bus layer, or aggregation layer, acts as a message broker. It forms a bridge between the data and the communication layer for the sensors. This is an important layer for three reasons. It supports an HTTP server and/or a MQTT broker. It aggregates and combines communications via gateway, and it bridges and transforms data between different protocols. The next layer is the event processing and analytics layer, which drives data and provides transformation to the data generated. It provides the ability to do event processing. The data is stored in the database. The client layer is used to create a web-based engine to interact with external APIs. This can be fed into the API management systems. This layer helps create a dashboard and provides a view of the analytics and event processing. This layer helps communicate with systems outside the network using machine-to-machine communication. So, we've seen the comprehensive IoT reference architecture with various components, rule engines, interfaces, and security systems embedded. Cross-functional architecture is possible using Device Manager that provides a single platform for remote management. The Device Manager communicates with devices through set protocols. Device management uses device management agents and is responsible for the remote management of software. The identity layer has the capabilities of cybersecurity, including policy control and OAuth 2-token insurance. Other capabilities include identity services, XACML, PDP, and directory of users, e.g., LDAP. IoT Reference Frameworks. There are a lot of frameworks for IoT setup, but the most common is the ISO 30141, and it provides commonly used vocabulary, reusable designs, and best practices for any developer to design an application. It also has many secure application standards that derive the maximum benefit for the organization and reduce the risks. IoT Standardization and Design Considerations. There are a number of IoT standards, and these are evolving over time. Some of the key ones are M2M, that is a machine-to-machine service layer that can be embedded in hardware and software to connect devices. Contiki, which is an open-source operating system for low-cost, low-power IoT microcontrollers. LightOS, a Unix-like operating system for wireless sensor networks. Random Phase Multiple Access. This is a proprietary standard for connecting IoT objects. The last one is Sigfox, a proprietary low-power, low-throughput technology for IoT and M2M communications. IoT Interoperability Challenges. IoT maturity comes with several challenges, specifically pertaining to interoperability and interfacing. The reasons are coexistence of multifarious systems, devices, sensors, equipment, etc., that interchange location time-dependent information in varied data formats, languages, data models, constructs, data quality, and complex interrelationships. Multi-vision system designed by manufacturers over time for varied application domains, making formulation of global agreements and commonly accepted specifications very difficult. New things that get introduced and that support a new unanticipated structures and protocols. Existence of low-power devices, which need to exchange data over lossy networks, and may have minimal likelihood or accessibility for a power recharge in months or years. IoT Design Considerations. When you choose an IoT solution, you need to consider several factors, like its wireless capability, functionality, interoperability, secure storage, immediate boot capacity, device categorization,
bandwidth, cryptographic control, and power management. The design considerations should be a mix of the estimated average of all these components and indexed to balance the user requirements. You also need to set up a dispute resolution mechanism in case of failure in the long run. IoT Device Architecture, Network, and Cloud. There are 4 stages of integrating the different IoT processes. Stage 1, network things, wireless sensors and actuators. Stage 2, sensor data aggregation systems and analog to digital data conversion. Stage 3, the appearance of edge IT systems. Stage 4, analysis, management, and storage of data. As these stages are evolving, the devices, the network, and the cloud application must be leveled equally in the ecosystem for better stability and security. The IoT architecture is a combination of things, devices, platform, and sensors with data. Stage 1 of an IoT architecture consists of networked things, typically wireless sensors and actuators. Stage 2 has internet gateways and data acquisition systems that includes sensor data aggregation systems and analog to digital conversion. In Stage 3, edge IT systems perform pre-processing of the data before it moves to the data center or cloud. Finally, in Stage 4, data center and cloud is where the data is analyzed, managed, and stored on traditional back-end data center systems. Fundamentally, we need to have a functional, scalable, available, and maintainable architecture. If these are not supported, then architecture is not useful. Now, let's look at the 3 architecture areas of IoT. 1. The client side, IoT device layer. 2. Operators on the server side, IoT gateway layer. And 3. A pathway for connecting clients and operators, IoT platform layer. These 3 layers interface with each other on the data synchronization front and pathway to generate more data from various applications. The feasibility of the layers depends on their application. Let us now differentiate between centralized and decentralized IoT architectures. The centralized architecture is a hub and is managed from one point, whereas the decentralized one is based on the use case. They do not help in the industrial IoT solution. The centralized architecture is associated with cloud architectures, in which a central hub provides a series of back-end services to smart devices. In decentralized architecture, there are many scenarios that require autonomous communication between smart devices in an IoT topology without the need of a central hub. The centralized systems help in event processing, and whereas decentralized systems operate more of peer-to-peer messaging. The decentralized auditing is one of the essential features in a decentralized architecture. Use case, IoT smart farming. Use case, smart farming, IoT design. This use case addresses the design formalities using IoT. IoT design is an essential part of the navigational ecosystem. Smart farming requires precise architecture and components that help bring benefits to the farmers. The various factors that determine the IoT design are data, cost, efficiency, and product quality. The efficiency and durability of the ecosystem help the farmers plan their harvest and sow based on the climatic conditions using the sensors and geospatial location data. So, to be precise, any farmer needs to understand the fundamental design that can help run the ecosystem. Smart farming is useful as it helps the farmer to predict conditions and sow crops with less cost and utilize the automation capabilities. To have such systems, you need to purchase the right hardware, which can monitor the accuracy of data and quality of the sensor. Once you have these systems, you can benefit more from farming. There are 4 things you need to integrate for smart farming. First is a data engine. Smart farming should have a robust data processing engine that can act as the brain and handle data processing, storage, and lead to efficient output. The second is hardware. You need to ensure that the hardware is durable and easy to maintain. Hardware with self-fixing algorithms is even better. The third aspect is mobile access. This is possible using a smartphone along with offline or online mobile applications. To enable all 3 processes, you need cloud infrastructure with the edge layer. This IoT system can enable smart farming for any crops in any geographical location. Let us look at another use case on using SIM cards to monitor sugar level in a diabetic patient. Diabetes management is a recurring concept where the patient has to check the blood sugar at regular intervals. In the traditional way, he has to go to the physician lab or he has to have his home blood glucose monitoring system. IoT can help create a system where the blood glucose data will be transmitted remotely via smartphone and a SIM embedded in it. Identifying the necessary and right hardware is one of the crucial steps of creating such a system. You need to choose the sensors for your device, or create a custom one which fits the glucometer. This can be a SIM card. The next step is to ensure that the quality of your sensors is good
and has seamless integration with the system. Finally, make sure that the data monitoring happens in real time with high accuracy. Now, when the hardware landscape of this ecosystem is ready, you need to set the software then. First, it is crucial that you have software with self-repair algorithm for service management. To enable this process, you need cloud infrastructure with edge, and finally, a smartphone to work with the devices and sensors. Key takeaways. Now that you have completed this lesson, you should be able to explain the IoT Reference Architectures and Frameworks, describe the IoT Interoperability and its design considerations, and finally, discuss industry-aligned use cases.
Here's a list of IoT projects for 2020. First up is Smart Mirror. Smart mirrors are a very cool IoT application. These mirrors can be used to display temperature, news, weather, calendar, clock, and compliments on the screen. Apart from these, smart mirrors can be used to click the perfect selfies with a built-in camera. It can also be installed with speakers to play some music, and they also provide on-demand workout sessions with world-class trainers. The mirror can be used to browse the internet, make phone calls, and even be connected with other devices for collaboration. Next up is Smart Money Transfer. We're heading towards complete digitization. Transactions are made possible on your cell phone with apps like Apple Pay, Google Pay, and PayPal. But imagine if you could walk to a store and pay with a wristwatch. Wouldn't that be cool? The purpose of the smart wallet is to provide an easy and reliable platform for money transactions. It is compact, wearable, and rechargeable. For safety purposes, the user authenticity is validated. The smart money transfer technology can reduce the burden of mobile money transfer. When you're on the go, you could easily step into a store, purchase the goods, and pay hassle-free. After every successful transaction, the balance is updated immediately to avoid any uncertainty. Next up is IoT Based Smart Arm. Now this project includes the creation of a robotic arm which can pick and place things from one place to another. To control this action, the robotic arm can be moved using specific commands. Some advanced arms allow the user to change the end effect of the arm to perform various different actions. It can be used to make art, print 3D images, and build production lines. It can also be used to perform your day-to-day chores. At number 4, we have Smart Irrigation. Now, with changing climate and recurrent water crisis, farmers suffer a great deal with growing crops. Smart irrigation puts an end to this ordeal. This system comes with a moisture sensor that checks the soil for its water content. When the soil moisture drops below a certain value, the system triggers the water supply. At number 5, we have Smart Door. Now, as the name suggests, this project aims at creating smart doors that control the entry and exit of humans. These doors open and close automatically when you pass by. The door can also be controlled remotely. You could unlock the door for a friend by tapping an icon on your smartphone. Once they exit, you're immediately notified. The owner can also choose who has the access to the door. At number 6, we have air monitoring system. Now, air monitoring has become crucial for the environment, and what better way to do it than incorporating IoT. The IoT system uses air sensors to sense the presence of harmful gases or compounds in the air. The data collected can be used by the local authorities to make a detailed analysis. Necessary actions can also be taken to ensure that the air quality levels don't reach an extreme low, especially in areas with hospitals and schools. Moving on to number 7, we have Smart Alarm Clock. Now, there are many variations of a smart alarm clock, but the alarm we are talking about is a self-setting alarm. This smart alarm clock uses your Google Calendar to check your appointments to set the alarm. It can also procure data from GPS about your ETA to a particular place and consider the weather to automatically adjust your wake time. All of this is just making life more easier. Moving on, at number 8, we have IoT-based weather reporting system. Now, the system deals with monitoring weather and climate changes like humidity, temperature, moisture, wind speed, UV radiation, light intensity, and even carbon monoxide levels in the air using multiple sensors. Now these installed sensors send data to the web page that is plotted as graphical statistics. The project even consists of an application that sends notifications as an effective alert to warn people about sudden and drastic weather changes. So when you're heading out, the app could easily tell you what the weather will be like and suggest carrying an umbrella or perhaps a sunblock. At number 9, we have Smart Wheelchair. There are over 132 million wheelchair users across the globe. Smart wheelchairs is an excellent innovation. Typically, it comes with built-in sensors on the seats that collect data every second. The data provides insight into the seating behavior of the patient and the energy required to maintain the posture. Other variations of smart wheelchairs could include fall detection. These features allow people to monitor the patient from a remote location. And finally, at number 10, we have Smart Street Light System. This IoT-based street light monitoring system not only monitors but also ensures low power consumption and detects faulty lights. The street lights have external sensing that automatically turns on at the desired intensity based on the lighting needed. Control of light intensity is based on the movement of people or vehicles. In case of an emergency, the lights increase their brightness to maximum intensity, thereby ensuring safety. When deployed as a part of a smart city, the users can be informed about any outages. They can also register a complaint for immediate service.
In this video, we will learn about Arduino. The Arduino platform has grown in popularity among those just getting started with electronics and for good purpose. In contrast to the majority of earlier programmable circuit boards, to load new code onto the Arduino, you don't need a separate piece of hardware. All you just need is a USB cable. Let's see what's in it for you in this session. We'll first start with understanding what is Arduino, followed by which we will see why to use Arduino. Then we will look at some of the important features of Arduino. After that, we will see the different types of Arduino boards. And at last, we will see advantages and disadvantages of Arduino. But before we begin, make sure you have subscribed to our YouTube channel and clicked on the bell icon so you never miss an update from Simplilearn. So without any further ado, let's get started. What is Arduino? Arduino is an open source electronic gadget that reads input such as light on a sensor, a finger on a button, or a tweet, and generates output based on those inputs such as turning on an LED or activating a motor. Arduino was created at a design institute as a simple tool for students with no prior experience with electronics or programming. Arduino boards are microcontrollers, not entire computers with operating system of their own like the Raspberry Pi. Arduino just runs C or C++ code that is stored in the firmware. The Arduino IDE is free software that allows you to create and upload code on an Arduino board. Why Arduino? Arduino has been used in millions of projects and applications due to its simple and accessible user interface. The Arduino software is simple to use for beginners, but it is customizable for advanced users. It works on Mac, Windows, and Linux systems. Arduino is a valuable tool for learning new skills. Anyone, including youngsters, amateurs, artists, and programmers, can begin tinkering by simply following the step-by-step instructions. It can be used by teachers and students to create low-cost scientific equipments, to demonstrate chemistry and physics principles, and to begin learning programming and robotics. Designers and architects create interactive prototypes, while musicians and artists create installations and try out new instruments. Features of Arduino. Arduino has microcontroller of Atmega 328 and the operating voltage is 5 volts, whereas the input voltage is recommended to be from 7 to 12 volts and input voltage limits from 6 to 20 volts. We have digital input-output pins, that is, we have 14 pins, and we have analog input 6 pins, and we have DC current per input-output pin 40 milliampere, and DC current for 3.3 volt pin is 50 milliamperes. And we have flash memory of 32 kilobytes, and we have SRAM of 2 KB and EEPROM of 1 KB, and we have clock speed of 16 MHz. Now let us look at the different types of Arduino boards present. Firstly, we have Arduino Uno. Arduino Uno includes everything you will need to get started. It has 14 digital input-output pins, 6 analog input, a USB port, a power jack, and a reset button. Among other features, it comes with everything you will need to get started with the microcontroller. Plug into a computer with USB cable or power it with an AC to DC adapter or battery. Next, we have Lilypad Arduino. Lilypad is wearable e-textile device created by Lee and designed in collaboration with SparkFun. Each Lilypad was cleverly constructed with large connection pads and a flat back to sew conductive thread into garments. In addition, the Lilypad features its own set of input, output, power, and sensor boards designed exclusively for e-textiles and can even be washed. Arduino Mega. The Arduino Mega is the larger brother of Arduino Uno. It contains many digital input-output pins, that is 54, and 16 analog inputs, a USB connection, a power jack, and a reset button. It comes with everything you will need to get started with microcontroller. Plug it into a computer with USB cable or power it with AC to DC adapter or a battery. Breadboard Arduino. The Arduino IDE can program the breadboard over the use of Mini B connector. It will run on Windows 8 without requiring changes to your security settings. Because of the USB chip we used, it's more sturdy and it's fully flat on the back, making it easier to integrate into your projects. And we have Arduino Leonardo. The Leonardo is Arduino's initial development board with a single microcontroller and USB port. As a result, it may be less expensive and easier. Additionally, because the board handles USB directly, code libraries are available that allow the board to imitate a computer keyboard, mouse, and other components. Now let us look at the advantages of Arduino. In comparison to the other microcontroller system, Arduino boards are comparatively affordable. The Arduino's module, its cheapest version, can be assembled by hand, and even pre-made Arduino module cost less than $50. For Windows, Macintosh OS X, and Linux, the Arduino Software IDE is provided. The vast majority of microcontroller systems are Windows only compatible. The Arduino software is simple for beginners, but it's also flexible enough for advanced users. For experienced programmers, the Arduino software is available as an open source tool to extend. People who want to learn more about the language can use C++ libraries, and those who want to learn more about technical specifics can switch from Arduino to AVRC programming language. The Arduino is an open source and has hardware that can be expanded. The Arduino board blueprints are made available under Creative Commons license, allowing experienced circuits designers to create their module version, extending and upgrading it. At last, we will look at the disadvantages of Arduino. Arduino cannot run multiple programs at a time. No memory safety checks. Expensive for CPU power and memory. It has lack of built-in communications. Lack of built-in peripherals. the limited number of programming languages, and a limited number of IDEs. In this video, we will discuss about Raspberry Pi. The Raspberry Pi Foundation developed a series of small single-board computers in the United Kingdom. So let's look at today's agenda. We'll first discuss what is Raspberry Pi. Then we will see some of the Raspberry Pi use cases, followed by which we will see the different types of Raspberry Pi boards available. Proceeding further, we will see the applications of Raspberry Pi, and lastly we will see the advantages and disadvantages of Raspberry Pi. But before we begin, make sure you have subscribed to our YouTube channel and clicked on the bell icon so you never miss an update from Simplilearn. So without wasting any further time, let's get started with what is Raspberry Pi. The Raspberry Pi is a small, low-cost computer the size of a credit card that connects to a computer monitor or television and utilizes a conventional keyboard and mouse. Raspberry Pi can do everything a desktop computer does, including accessing the internet. Using Raspberry Pi, we can watch high-definition videos, access spreadsheets, word processing, and play games. The Raspberry Pi can communicate with the outside world and has been used in a variety of digital maker projects. Raspberry Pi is also used in music machines and parent detectors, as well as weather stations and tweeting bird houses with infrared cameras. Raspberry Pi use cases. Raspberry Pi is used in computer desktop. A simple desktop can be built using a Raspberry Pi, a micro SD card and a power source, an HDMI cable and a suitable display, such as an old monitor, are also required. You will also need a USB keyboard and a mouse. Robotics Controller. There are numerous Raspberry Pi robot controller projects. A specific robotics package for Pi is available, which is powered by the device battery and can be used to interface with and control robots. Printing using a Raspberry Pi. With the Raspberry Pi, we can print anything. All we need is Raspberry Pi that's connected to your home network, as well as some print server software. This is accomplished by first installing the Samba file sharing program, then CUPS. CUPS stands for Common Unix Printing System, includes printer drivers as well as management console. Game Server. The basic operating system for Raspberry Pi has a special version of Minecraft game pre-installed. The Raspberry Pi applications can be used as a game server. It's fantastic Minecraft game server. A wonderful gaming experience can be created by using many Raspberry Pi. Game Machine. As a retro gaming machine, the Raspberry Pi is perfect. It is one of the machine's lightest components. The Raspberry Pi Zero, in particular, is a variant that can fit into small locations and be used for gaming projects. The Raspberry Pi may also be used to restore many popular 16-bit game systems. Now let us look at the types of Raspberry Pi. The different types of Raspberry Pi are Raspberry Pi Model B, Raspberry Pi Model A, Raspberry Pi Model B+, Raspberry Pi Model A+, Raspberry Pi Zero, Raspberry Pi 2, Raspberry Pi 3 Model B, and Raspberry Pi Zero W. The different applications of Raspberry Pi are: it is used as media streamer, tablet computer, internet radio, home automation, robotics command, arcade devices, cosmic computer, and different Raspberry Pi projects. Now let us look at the advantages of Raspberry Pi. Raspberry Pi is about the size of a credit card. The Raspberry Pi is inexpensive. Using Raspberry Pi to function as a server is more efficient than using a regular server. The Raspberry Pi is ideal for adaptive technology because it can display visuals as well as play movies. The microcomputer can be used by small businesses on a tight budget to use their product or build new technology that integrates the product. Now let us look at the disadvantages of Raspberry Pi. Raspberry Pi is not a computer replacement, and the processor is not as fast. Downloading and installing software takes time, so you won't be able to do any intricate multitasking. Other operating systems such as Windows are incompatible. This product will not be beneficial for large-scale businesses that already have large servers, which can perform all the tasks that Raspberry Pi can. As a result, it would not be worth it, and putting everything together, it would take time. In this video, we will see Arduino versus Raspberry Pi. Let us look at today's agenda. We'll first start with understanding what is Arduino. After that, we will look at what is Raspberry Pi. Then we will see a comparison between Arduino versus Raspberry Pi on the following parameters: control unit, architecture, specifications, operating system, licensing, applications, and types of boards. And at last, we will see which is better, Arduino or Raspberry Pi. But before we begin, make sure you have subscribed to our YouTube channel and clicked on the bell icon, so you never miss an update from Simplilearn. So without wasting any further time, let's get started. What is Arduino? Arduino is an open source electronic gadget that reads inputs such as light on a sensor, a finger on a button, or a tweet, and generates output based on those inputs, such as turning on the LED or activating a motor. Arduino was created at a design institute as a simple tool for students with no prior experience with electronics and programming. Arduino boards are microcontrollers, not entire computers with operating systems of their own, like the Raspberry Pi. Arduino just runs C, C++ code that is stored in the firmware. The Arduino IDE, Integrated Development Environment, is free software that allows you to create and upload code to an Arduino board. Now let us see what is Raspberry Pi. Raspberry Pi is a small, low-cost computer the size of a credit card that connects to a computer monitor or television and utilizes a conventional keyboard and a mouse. Raspberry Pi can do everything a desktop computer does, including accessing the internet. Using Raspberry Pi, we can watch high-definition videos, access spreadsheets, word processing, and play games. Raspberry Pi has a dedicated processor, memory, and a graphics driver, just like a PC. It also comes with its own operating system, Raspberry Pi operating system, which is a modified version of Linux. Raspberry Pi is also used in music machines, parent detectors, as well as weather stations and tweeting birdhouses with infrared cameras. Let us look at the comparison between Arduino versus Raspberry Pi. First, let us look at the control unit. Arduino is a member of Atmega family of microcontrollers. A microcontroller chip common on Arduino Uno boards is Atmega 328. The 8-bit AVR microcontroller family includes Atmega 328 microcontrollers. A surface mount Atmega chip is seen on some Arduino Uno boards. The Raspberry Pi is an ARM controller unit. Broadcom chips based on ARM's Cortex-A application processor have powered Raspberry Pi from its release. The Raspberry Pi 3 is the latest version of the Raspberry Pi, launched in February 2016. It has 1.2 GHz ARM Cortex-A53 CPU, making it compatible for the ARM63. It has 1.2 GHz ARM Cortex-A53 CPU, making it compatible for the ARM64 architecture. Architecture. The Harvard architecture is used by Arduino's CPU, which means that the program code and the program data have distinct memory. It is made up of two types of memories, program memory and data memory. The data is saved in the data memory while the code is kept in the flash program memory. Whereas in Raspberry Pi contains a single core ARM V6 processor running at 700 MHz, a video core, 4 GPU, and 512 MB of RAM. Its operating system and data are stored on SD card. Raspbian, a lightweight Linux operating system based on Debian, is officially supported by the Raspberry Pi. Licensing. Arduino is an open-source electronics platform that uses simple hardware and software to make it easy to use. It's for everyone who wants to make interactive projects. Arduino perceives the environment by receiving data from a variety of sensors and actuators to influence its surroundings. Raspberry Pi's hardware and software are both proprietary. Raspberry Pi has never claimed to be open source. Many aspects of it, particularly the software, are open source, but not all of it is. The Raspberry Pi has been criticized for having closed source components. Operating system. Arduino boards are single board microcontrollers with firmware and no operating system. A firmware program is a piece of software that is installed on hardware device. It doesn't have an operating system, but it does have a firmware which can be programmed using several IDEs, including the Arduino IDE. Raspberry Pi operating system for PC and Mac is Debian with Raspberry Pi Desktop. It installs the Raspberry Pi operating system desktop on PC or Apple Mac, as well as most of the recommended software that comes with Raspberry Pi operating system. Now let us look at the specifications. So we look at the specifications between Arduino Uno R3 and Raspberry Pi 3 model B+. So if we look at the system, Arduino has microcontroller system, whereas Raspberry Pi has single-boarded computer. Processor. Arduino has AVR at Mega 328P and Raspberry Pi has Broadcom. RAM. In Arduino Uno, we have RAM of 2 KB, whereas in Raspberry Pi Model 3 B+, we have 1 GB RAM. Clock speed 16 MHz in Arduino and 1.4 GHz in Raspberry Pi. Execution. In Arduino, single program can be executed at a time, whereas in Raspberry Pi, multiple programs can run at a time. Current. Current is 5 mA in both Arduino and Raspberry Pi. And GPU I/O pins, Arduino has 20 and Raspberry Pi has 40. And power consumption in Arduino is 175 mW and in Raspberry Pi it is 700 mW. Applications. Arduino is used in waving machines, traffic light countdown timer, parking lot counter, embedded systems, home automation, industrial automation, medical instrument, and emergency light for railways. Whereas Raspberry Pi is used in desktop PC, wireless usage, game servers, retro gaming machine, robot controller, stop motion camera, and time-lapse camera. Now let us look at the different types of Arduino and Raspberry Pi. In Arduino, we have Arduino Uno, Lilypad Arduino, Arduino Mega, Arduino Leonardo, Arduino Redboard, and Arduino Shields. Whereas in Raspberry Pi, we have Raspberry Pi 1 Model B, Raspberry Pi 1 Model A, Model B+, Model A+. Then we have Raspberry Pi 0, Raspberry Pi 2, Raspberry Pi 0W, and Raspberry Pi 3 Model B. Arduino or Raspberry Pi, which is better? The Arduino and Raspberry Pi have their own set of benefits and drawbacks. The best option for you will be determined by the requirement of your project and your budget. Arduino is ideal for automating repetitive operations such as opening and closing doors, turning on and off lights, and so on. Arduino should be the first pick if your project has any repeating elements and just requires generating output depending on sensory inputs. Raspberry Pi is ideally suited for complex activities such as controlling complex robots, weather monitoring, and internet publishing, among others. If your project necessitates advanced functionality as well as internet access, then the Raspberry Pi is the option.
We will be learning about the top Arduino projects for 2022. But before we begin, let me tell you guys that we have daily updates on multiple technologies. So If you're a tech geek in a continuous hunt for latest technological trends, then consider getting subscribed to our YouTube channel and don't forget to hit that bell icon to never miss an update from Simplilearn. Now without further ado, let's get started with the agenda for today's session. So we will get started by understanding what exactly is Arduino, and followed by that, we will get started with top Arduino projects for 2022. And once we are done with the top Arduino projects, we will understand the fundamental differences between Arduino and Raspberry Pi. I hope I made myself clear with the agenda. Now without further ado, let's get started with our first topic, that is what exactly is Arduino. Over to our experts.
In this video, we will be discussing about Arduino projects, the different domains where Arduino can be used and how. Let's look at today's agenda. We'll first look at locking projects using Arduino. Then we will look at some of the rover projects using Arduino, game projects using Arduino, then automation projects using Arduino, followed by which we will look at robotics projects and health projects. Then we will look at some of the drone projects, audio projects, IoT projects, and lastly, we will look at sensor projects using Arduino. But before we begin, make sure you have subscribed to our YouTube channel and clicked on the bell icon so you never miss an update from Simplilearn. So without wasting any further time, let's get started. Locking projects using Arduino. Frequently, we need to secure a space in our home or business so that no one can enter without our permission and our valuable accessories and assets are protected from theft or loss. There are many different types of security systems available today, but they all rely on fingerprints, retina scanners, iris scanners, face ID, tongue scanners, RFID readers, password pins, patterns, and other biometrics for authentication. The most cost-effective solution is to utilize an Arduino-based password or pin-based system. Some of the locking projects using Arduino are Arduino door lock system, RFID and keyboard lock system. We have unlock door with knock system, push button lock system, and gesture control lock using Arduino. Then we have rover projects using Arduino. The Arduino Robot is the world's first Arduino-powered vehicle. On each of robot's two boards there are two CPUs. The motor board is in charge of the motors, while the control board is in charge of reading sensors and deciding how to run them. Each board is a complete Arduino board that can be programmed using Arduino IDE. Using Arduino, we can create many rover projects like voice controlled rover, line follower rover, gesture controlled rover, survey rover, IR remote controlled rover, and similarly we have autonomous rover and many more. Game projects using Arduino. Some remarkable Arduino-based game projects ranging from retro gaming played on a little screen to more sophisticated projects requiring some assembly. Some of the Arduino gaming projects are Snake Game, then we have Chess Game, Pinball, Spaceship Simulator, and Claw Machine. Automation projects using Arduino. The robust characteristics of Arduino are well suited to a popular section of applications, that is automation. The Arduino board can be used to create a wide variety of automation applications. Automation has brought convenience to a whole new level, from controlling room lights with your smartphone to automatically organizing events. Instead of using mechanical switches, you can now operate all of your home electronics from the palm of your hand. Some of the automation projects using Arduino are home automation and sanitizer dispenser, automated shower boiler, automatic motion sensor trash, and IR remote controller home appliances. Health projects using Arduino. Any medical equipment that has internet connectivity and can measure one or more health data of a patient who is connected to the device, such as heartbeat, body temperature, blood pressure, ECG steps, etc., is referred to as Arduino-based patient health monitoring system. If there is a rapid change in patient's health, the equipment can record and transmit the data. IoT encompasses everything from smart watches to fitness tracker to hospital equipment that can link to the internet. Arduino-based health projects are being developed to create new medical gadgets. It may be used to measure body factors such as ECG, temperature, moisture, and heartbeat. It also identifies the patient's physical state and location. Some of the health projects using Arduino are Smart Wristband, Smart BioWare, Portable ECG, Ultrasonic Sight, and Smart Health Kit. Drone projects using Arduino. Drones are airborne vehicles that range in size from micro to multi-rotor quadcopters. A camera is sometimes included with the drone, allowing the users to watch and record the bird's eye perspective. A drone is made up of numerous parts, one of the most significant of which is the flight controller, which acts as the drone's brain. The Arduino development board is great for this purpose, especially because there are a variety of models available ranging from the tiny Arduino Nano to Arduino Mega, all of which are small enough to fit into the design of a drone. Some of the drone projects using Arduino are quadcopter, autopilot drone, mind control drone, guide power drone, and hovercraft. Robotics project using Arduino. We can learn about electronics, mechanics, and software using the Arduino Robotics project. It includes a number of project examples that you can easily copy, as well as robust robotics platform that you may hack to execute a variety of jobs. Some of the robotics projects are robotic arm, drawing robot, firefighter robot, ball tracking robot, and spider robot.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Audio projects using Arduino. If you enjoy working with both hardware and software, Arduino is the perfect hobby for you. Arduino is a programmable, logical controller that can do a variety of cool things depending on your programming skills. Using the Arduino to make music is a special genre of projects. If you will, some are straightforward to implement while others are more difficult. So some of the Arduino projects for audio are Paper Piano with Arduino, VFO or RF generator, Arduino MP3 player, Arduino Uno guitar pedal, and Arduino beat detector. And we even have mini vintage internet radio, Morse code communication using Arduino, and many more. IoT projects using Arduino. Arduino IoT Cloud is a tool that allows creators to create connected products quickly, easily, and securely. Multiple devices can be linked together and data can be exchanged in real time. You can also keep an eye on them using a simple user interface from anywhere. Some of the IoT or Bluetooth projects using Arduino are IoT Bicycle Radar, IoT Pet Feeder, Telegram Bot, Arduino Bluetooth Camera, and Smart Parking System. Sensor projects using Arduino. One of the aspects that make an Arduino so valuable is the simplicity with which it can retrieve sensor information. Sensors are devices that transform a physical quantity into an electrical quantity, such as light intensity or temperature. The different types of sensors that are available are light sensor, motion sensor, temperature sensor, magnetic field sensor, gravity sensor, humidity sensor, moisture, vibration and pressure sensor, electrical field sensor, sound sensor, and position sensor. Manufacturing, machinery, aircraft, vehicles, medicine, and robotics are just few of the use cases of these sensors. So the different sensor projects that can be made using Arduino are temperature monitoring, smoke detection using gas sensor, 3D scanner, smart plant incubator, and water quality monitoring system. In this video, we will be discussing about Raspberry Pi projects. The Raspberry Pi has a wide range of uses. The microcomputer has grown to accomplish many odd activities in addition to many standard tasks. Raspberry Pi was created with the intent of allowing people to play with the circuit board and to aid in the development of new computing skills. The internet is huge amount of information about the Raspberry Pi's various applications and projects, as well as recommendations on how to execute them. We will go over a few projects that demonstrate the microcomputer's wide range of capabilities. This video will show you the most popular and useful projects. But before we begin, make sure you have subscribed to our YouTube channel and clicked on the bell icon so you never miss an update from Simplilearn. So without any further ado, let's get started. The first project is web server. The Raspberry Pi serves as a web server for multiple users. There are numerous web server packages to choose from. However, in the most circumstances, the Raspberry Pi's performance is insufficient for reliably hosting large amount of dynamic online content. Instead, the mini computer is significantly better suited for local testing environment. Simple static websites with low visitor counts, on the other hand, might be hosted on Raspberry Pi server. Scanner server. Setting up your Raspberry Pi as a scanner server using Sane is a terrific way to bring your old scanner up to date. Instead of purchasing a Wi-Fi capable scanner, you can use a device like Raspberry Pi Zero to provide that capabilities. Scanner Access Now Easy is the acronym for Sane. This program serves as a standardized method of gaining access to the scanners. Xbox Cloud Gaming on Raspberry Pi. Microsoft's Xbox Cloud Gaming service allows you to stream various video games from their servers to another device. In this project, we will be streaming these games from the Xbox Cloud Gaming service to the Raspberry Pi. Using the Chromium web browser, you can broadcast Xbox Cloud Gaming to your Raspberry Pi in a reasonably simple manner. This project will even show you how to turn your Raspberry Pi into pure Xbox Cloud Gaming machine. The Xbox Cloud Gaming service isn't the only game streaming option for your Raspberry Pi. You can also broadcast games to use Pi using Google's gaming service. Game console. We can turn your Raspberry Pi into a retro gaming console. Also, we can now simulate practically any classic game from 1970s to the 1990s using this little computer. RetroPie, a piece of software that solves all of your emulation needs, is now available. It's a simple piece of software to set up, and it also offers a user-friendly interface. You may now play old games with RetroPie. You can use any Raspberry Pi model for this project. However, the Raspberry Pi 4 model, such as the Raspberry Pi model 4B, that is 4GB, is strongly recommended. Remote Control 3D Printer. Octoprint, which is one of the most well-known 3D printing program, can also be used on Raspberry Pi. This software lets you collect statistics and even monitor your 3D printer from afar. You can now control your 3D printer remotely rather than using an SD card. Aside from that, you can connect a webcam to your 3D printer to monitor the progress of your printing. You will need a Wi-Fi adapter like the model TL-WN725N to make your 3D printer work, because you will need to connect it to the internet. Language translator. This project necessitates some coding and programming experience. We can utilize the Google Translate library or any other Python translating tool to make this project much easier. You will need to know how to set up text-to-speech, speech recognition, translation APIs, and so on because this project has many layers. Overall, it's still a worthwhile project that you can do with your Raspberry Pi and add to your achievements of Raspberry Pi projects. Security camera. You may have observed that different Raspberry Pi models are compatible with different camera modules. The Raspberry Pi 8 megapixel camera module, for example, is only compatible with Raspberry Pi 1, 2, and 3 versions. You may now make your own security camera for your home with this camera module. Another advantage of this project is that you can add whatever other features you like. For example, we can access video feeds from afar and have them immediately uploaded to a server for backup. A number of package or library prerequisites are already available on the internet. On your Raspberry Pi, you can simply download or alter it. Wi-Fi extender. A Wi-Fi extender is another simple project. It's a low-cost and effective solution to increase Wi-Fi range. If you have a bad Wi-Fi signal in your garden or even your room, you may utilize your Raspberry Pi to boost your signal. It's an excellent substitute for a commercial Wi-Fi repeater. Furthermore, because this is a DIY project, you can always alter it and add new features. Because this job has already been completed by many people, you can just search the internet for the finest and most convenient way to complete it. Running Android TV on Raspberry Pi. Android TV is a specialized version of Google's famous mobile operating system. It has a revised interface that better accommodates the horizontal nature of television screens. Because the operating system is better suited to wide horizontal screens and remote controls, it's the best option for connecting the Pi to your TV. The Google Play Store also gives you access to many downloadable apps. The most significant difficulty with running Android TV on a Raspberry Pi right now is that builds lack hardware video decoding and encoding capabilities. The Pi 4 Module B, Pi 400, and the Compute Module 4 are the only devices that can run Android TV. Running Zoom on the Raspberry Pi. We can utilize the feature to set up meetings so that people can readily connect with you. The individual hosting the meeting, on the other hand, will need their own Zoom account. The person who creates the meeting has the authority to determine who is allowed to speak and share resources such as the computer screen. With the free plan, you can connect up to 100 additional individuals for a total of 40 minutes. Because the Raspberry Pi does not contain any ARM binaries, it is difficult to run Zoom on it. We will use a handy piece of software called Box86 to get around this. Box86 is an emulation program that transforms 86 instructions to ARM instruction set, which the Raspberry Pi recognizes. Raspberry Pi Bluetooth speakers. You may greatly expand the capabilities of your Raspberry Pi by connecting it to a set of speakers. This project gives you the opportunity to stream audio directly to any vintage speakers or hi-fi system, making them more modern. We can add support for Apple, AirPlay, Spotify, Connect, and synchronize multiple room audio to Raspberry Pi in addition to Bluetooth audio. We are going to utilize a ballerina image named Ballerina Sound to bring all of these extra capabilities to our Raspberry Pi. This instruction from Ballerina greatly simplifies the setup process and should lessen the chances of making mistakes. Home Assistant using Raspberry Pi. Home Assistant is an open source home automation program that was created using Raspberry Pi based devices. The software was created with the goal of protecting your privacy and retaining control in the hands of the user. You can monitor the status of all of your devices in your house with the Home Assistant. You can even automate your interactions with them. We can program Home Assistant to turn on all of the lights automatically when it gets dark and you're at home. When you cast a movie on your Chromecast, you can even program it to dim the lights in your living room. Raspberry Pi is an excellent platform for home automation. It's compact, inexpensive, has many networking functions, and consumes little power.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Minecraft using Raspberry Pi. For this project, we need to install a custom version of Minecraft designed just for Raspberry Pi. Minecraft Pi Edition is the name of this version of Minecraft. This version of Minecraft is much older than the current version. It does, however, have an advantage. It is entirely free. Additionally, this version of Minecraft includes a Python library for interacting with the game environment.
In this video, we will discuss about a particular type of Raspberry Pi, that is Raspberry Pi Zero. See what's in it for you in this session. We'll first start with understanding what is Raspberry Pi. Followed by, we will see some of the features of Raspberry Pi Zero and specifications of Raspberry Pi Zero. Then we will see applications and the difference between Raspberry Pi Zero and Raspberry Pi Zero W. But before we begin, make sure you have subscribed to our YouTube channel and clicked on the bell icon so you never miss an update from Simplilearn. The Raspberry Pi Zero. The Raspberry Pi Zero is a super cheap, super compact computer. The Zero is smaller than a credit card, measuring 65mm by 30mm and is only 5mm thick. It also weighs 9 grams. The Raspberry Pi Zero is inexpensive, costing only $4 to $5. The Raspberry Pi Zero W is member of the Pi Zero family with wireless LAN and Bluetooth capabilities. The Raspberry Pi Zero uses the same single-core Broadcom CPU as the original Raspberry Pi. However, it has been turned to 1 GHz, making it 40% faster than the original. When you consider the Zero Raspberry Pi with 512 MB of RAM, it's around 3 times faster than the original Raspberry Pi in terms of total performance. Features of Raspberry Pi Zero. The Raspberry Pi Zero has a single tiny HDMI port rather than the full HDMI port found on prior Raspberry Pi devices. Despite this, it can still produce video at 1080p and 60 frames per second. One micro USB port provides power to the Raspberry Pi Zero, while the other serves as the USB out port for connecting a keyboard, mouse, Wi-Fi dongle or other peripheral. There is no standard Wi-Fi or Ethernet port on the Raspberry Pi Zero. You will have to figure out how to connect to the internet on your own. But that's the kind of purpose of this bare bones gadget. It has an unpopulated 40-pin GPIO header and an unpopulated composite video header. Just as all other Raspberry Pi variants, you can use this to solder on your own interface components if you like, which is where the Raspberry Pi's enormous potential and flexibility really shine. Another important cost-cutting technique is the lack of fixed storage on Raspberry Pi Zero. Instead, you will need to provide your own storage in the form of micro SD card, which you may place into the provided slot. The Raspberry Pi Zero, like previous Raspberry Pi devices, runs on Raspbian. It's lightweight operating system based on the Debian operating system open source project. Being free to download, Raspbian also gives users access to PiShop, which is essentially an app store with hundreds of packages built particularly for the Raspberry Pi. Given the Raspberry Pi Zero's capable hardware, it can just run about any packages. Now let us look at the applications of Raspberry Pi. The Raspberry Pi Zero is already a computer that can be used as a desktop PC or notebook without the need for a screen or keyboard. Some of the applications are: it is used to make a wildlife camera. This is the droid you are looking for. Build a portable pocket-sized computer, a compact Raspberry Pi Zero server, binary clock with Unicorn P-hat, ZeroBot Raspberry Pi Zero FPV Robot, Remote Controlled Smart Drone, Raspberry Pi Zero Wi-Fi Security Camera, Portable Game Console, Home Network Music System, Google Home with Bluetooth speaker, and many more. Specifications of Raspberry Pi Zero. Some of the specifications of Raspberry Pi Zero are: it has 802.11 wireless LAN, Bluetooth of 4.1, Bluetooth Low Energy, and 1 GHz single core CPU, 512 MB of RAM, mini HDMI port and micro USB OTG port, micro USB power, HAT compatible 40-pin header, composite video and reset headers, and CSI camera connectors. Now let us look at the difference between Raspberry Pi Zero and Raspberry Pi Zero W. The W in Raspberry Pi Zero stands for wireless, and it denotes the Pi Zero model's wireless functionality. That is the most significant distinction between the two models. While the Raspberry Pi Zero was designed to deliver more functionality while being half the size of A+ board. Later, the Raspberry Pi Zero W was released with built-in wireless connectivity, eliminating the need for a separate accessory or module to enable Bluetooth and Wi-Fi. The Raspberry Pi Zero is $5, whereas the Raspberry Pi Zero W is roughly $10. The price will of course vary depending on its availability and location. The main distinction between two is this, with the rest of specifications staying the same.
In this video, we will discuss about Raspberry Pi 4. Let's see what's in it for you in today's session. We'll first start with understanding what is Raspberry Pi 4. Then we will look at some of its features and specifications, and lastly we will see the applications of Raspberry Pi 4. But before we begin, make sure you have subscribed to our YouTube channel and clicked on the bell icon so you never miss an update from Simplilearn. What is Raspberry Pi 4? The Raspberry Pi 4 Model B, which is a 1.5 GHz 64-bit quad-core ARM Cortex A72 processor, which was released in June 2019. When utilized with an adequate power supply, the Pi 4 can also be powered using a USB-C connector, allowing for more power to be delivered to downstream peripherals. Raspberry Pi 4 can do everything a desktop computer does, including accessing the internet and watching high-definition videos, as well as spreadsheets, word processing, and gaming. The Raspberry Pi 4 is capable of handling a wide range of tasks, including reading articles, like watching videos and working with the text. Features of Raspberry Pi 4. Raspberry Pi 4 has improved speed and performance over previous generations. We have created a complete desktop experience for the first time. Whether you're editing documents, browsing the web with multiple tab opens, wrangling spreadsheets, or creating a presentation, the experience will be smooth and familiar. Multiple USB ports. The USB ports on your Raspberry Pi 4 has been upgraded. In addition to the two USB connections, there are two USB 3 ports, which can transport data up to 10 times quicker. Quick networking. Gigabit Ethernet, interconnected wireless networking, and Bluetooth are included with the Raspberry Pi 4. Silent and energy saving. The Raspberry Pi is fanless, energy-efficient computer that works quietly and consumes significantly less electricity than traditional PCs. RAM selection. Depending on how much RAM you need, Raspberry Pi offers multiple variants: 1 GB, 2 GB, 4 GB, and 8 GB RAM. Now let us look at the specifications of Raspberry Pi 4. Raspberry Pi has Broadcom quad-core Cortex A72 ARM version 8 64-bit processor. It has 1 GB, 2 GB, 4 GB, or 8 GB SDRAM. It has 2.4 GHz and 5.0 GHz IEEE wireless Bluetooth of 5.0. It has gigabit Ethernet, 2 USB 3.0 ports, and 2 USB 2.0 ports, Raspberry Pi standard 40-pin GPIO header, 2 micro HDMI ports, 2 LAN MIPI DSI display port, 2 LAN CSI camera port, 4-pole stereo audio and composite video port, micro SD slot for loading OS and data storage, 5V DC USB-C connector and 5V DC GPIO header, and power over Ethernet is enabled. And lastly, operating temperature is between 0 to 50 degrees Celsius.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Now let us look at some of the applications of Raspberry Pi 4. Raspberry Pi 4 is used for portable game console, home network music system, Google Home with Bluetooth speaker, Raspberry Pi home security system, social media bot using Raspberry Pi 4. Then we have Raspberry Pi based retro gaming system, machine learning on Raspberry Pi 4, Raspberry Pi 4 Wi-Fi security camera, remote controlled smart drone, portable pocket sized computer.
Now with that, we have come to an end of this session on the IoT full course. If you have any queries regarding any of the topics covered in this session, or if you require the resources that we used in this session, then please feel free to let us know in the comment section below, and our team of experts will be more than happy to resolve all your queries at the earliest. Until next time, thank you, stay safe and keep learning.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.